If you've had a physics class before, then you've probably heard the term kinematics. But what is it really? Simply put, kinematics refers to the study of motion. In order to describe this motion, we use 4 specific properties, which are position, velocity, acceleration, and time. Each of these properties of motion has its own definition formula. The definition formula for position is velocity times time in units of meters. The definition formula for velocity is change in position over change in time in units of meters per second. And the definition formula for acceleration is the change in velocity over the change in time in meters per second squared. If we apply some calculus to these definition formulas, rearranging and deriving them, we get what we call the kinematic equations, which are useful when we're given a bunch of data in a problem. Let's quickly go over an example. If a student walks to class with an initial velocity of 3 meters per second and 10 seconds later her speed has increased to 8 meters per second, what was the acceleration rate within that interval of time? First, we're going to underline our important data. This will help us create a list of givens. In this case, we have an initial velocity of 3 meters per second, a time of 10 seconds, and a final velocity of 8 meters per second. We're looking for acceleration. Looking at our knowns and unknowns, we can refer to our kinematic equations and see which one is more appropriate. In this case, the second one is going to be the most appropriate because we have a v final, v initial, time, and we're looking for an acceleration. After choosing our equation, we can go ahead and plug those knowns into the equation and solve for the unknown. That process would look like this. We would be left with 8 equals 3 plus 8 times 10. Then we subtract 3 on both sides, and we are left with 8 minus 3 is equal to 8 times 10. We divide 10 on both sides, canceling them out. 8 is equal to 8 minus 3 over 10, which simplifies to 5/10 equal to 1/2. And finally, acceleration equals 0.5 meters per second squared. Essentially, what we just did was finding what was the acceleration rate needed to go from an initial velocity to a final velocity in a given interval of time. We found that acceleration was 0.5 meters per second squared. Here's a bit of a more complicated example. Driving along the highway at 108 kilometers per hour, you look out the window. If you were looking out the window for 2.1 seconds, how much distance did you cover during the elapsed time? Velocity is constant. First, we underline our givens and write our list of givens, and then what we're looking for. After this, our process will be first to convert to the right units. In this case, we're going from kilometers per hour to meters per second. Step 2 is to pick an equation based on the given data once everything is homogeneous. So we have a constant velocity, therefore an acceleration that's 0, and a given time. We're looking for a change in position. So step 3 will be rearranging your equation to solve for your unknown, which is change in position. The fourth step will be to plug in your data into your rearranged equation. In this case, we plug in 30 for velocity, 2.1 for time, and 0 for acceleration. This yields a change in time of 63 meters. Finally, these are some things to take note of. Notation for position can vary depending on the direction of movement. Usually up or down movement we use Y, and for left or right movement we use X. Next, the terms velocity and speed are often used interchangeably. The only difference between the two is that velocity includes a direction and magnitude, while speed only includes magnitude without regard for direction. This is why we can express speed as the absolute value of velocity. Finally, the force of gravitational pull always produces an acceleration relatively downwards or towards the center of the Earth of 9.81 meters per second squared. We call this constant g. Well, that was all for this video. I hope it helped you gain a little bit more understanding, and thank you for watching.